Chapter 13 of our text deals with abstract classes and with interfaces. So those are the topics we're going to cover now. By now you've learned quite a bit about normal classes, which we call actually concrete classes, and we're going to compare those to abstract classes. The distinction between the two is really the methods. In the case of abstract classes, the methods are abstract as opposed to concrete, and what that means is they do not have any implementation. In effect, they're sort of a placeholder. The implementation will be provided by a class that extends from an abstract class. A direct result of this is that it's impossible to create an instance of an abstract class using the new operator. In other words, it's not possible to create an object of an abstract class, only of a concrete class. Interfaces, by contrast, are something like class constructs, except they only are allowed to contain constants and abstract methods. Since Java 8, there's been a slight change to that, and now interfaces are also allowed to have default methods and static methods. One point about abstract methods is they are non-static. It is not possible to have a static abstract method. We're now going to revisit the UML diagram for our circle and rectangle class, which you recall inherited from the geometric object class. There are some differences now, though. First of all, you'll notice that in addition to the minus and plus signs in the geometric object to indicate visibility of private and public respectively, now we have the introduction of a new visibility modifier, the sharp sign or the pound sign, and that indicates protected visibility. What that means is that these constructors are going to be visible to the child and rectangle classes because they extend the geometric object class. However, they will be private as far as other objects are concerned. Another thing you'll notice is the introduction of some italics. Right at the top, the geometric object title is shown in italics this time, and that indicates an abstract class. Likewise, down at the bottom, you'll find two methods that are now abstract and therefore italicized. So the getArea method and the getPerimeter method are both shown in italics. Because of the existence of these two abstract methods, that makes this class an abstract class. That means that once we've done this, that is, we've made those two methods at the bottom abstract, we're no longer able to make objects of geometric object. And furthermore, when we extend this abstract class into the concrete class of circle or rectangle, we're obliged to make those the getArea and the getPerimeter, that is these two abstract methods, into concrete methods. In other words, we need to provide an implementation for both of these. So to summarize, there is no implementation for getArea or getPerimeter in the geometric object class. There can't be, really, because the area for a circle is calculated in a different way than it is for a rectangle, and the perimeter as well is not calculated the same way in the case of a circle as it would be in the case of a rectangle. Therefore, these two methods effectively are here as placeholders. They're abstract. They do not contain an implementation because it's up to the individual classes which extend the geometric object to determine how these two things are going to be calculated. So now let's talk about how our geometric object class is going to look a little bit different now that we've defined it to be an abstract class. Well, the first thing you'll notice is that instead of just declaring public class geometric object, we now say public abstract class geometric object to indicate that it's an abstract class now. The rest of the implementation remains unchanged, except now we've added two abstract functions to it, or methods, that didn't exist before. So those are shown in red at the bottom of the slide. The first is the getArea method and the other is the getPerimeter method. So we declare getArea to be a method that is public abstract double getArea. So it's going to return a double, but there is no implementation, not even an empty implementation. In other words, you don't even see a pair of curly brackets with nothing inside of them. Those are not even present. We simply have a semicolon ending that line, and that's all we have. So it's very clear then that there is absolutely no implementation at all present for the getArea method. Moving down below and looking at the declaration for get perimeter, we have the same story here. It's declared to be an abstract method by virtue of the word abstract being in its method signature. And again, you'll notice that right after the signature, we go straight to a semicolon. Not only are we missing a block with curly braces that would normally have an implementation, but in fact the curly braces themselves are even missing. There's simply nothing there because there is absolutely no implementation provided whatsoever for an abstract function or an abstract method. In this discussion, we're not going to bother showing or talking about our implementations for the circle class or the rectangle class. We've already seen those, and those aren't going to change. They already have methods in them for getting the perimeter and getting the area, and those things are not going to change. All we're going to talk about is how those things fit in the context of our now abstract geometric object class. If you look up at the top of this slide, you'll notice that we declare two objects, GeoObject1 and GeoObject2, immediately beneath the signature for the main method. Notice that the declared type in each of those cases is geometric object, which is an abstract class. That means we're not going to be able to make the objects from this using the new. However, notice what we've done instead. In the case of GeoObject1, we've used the new operator, but not with geometric object because we can't. Instead, we've used new circle and used the one-arg constructor for this. In the case of GeoObject2, we've used new, but this time with the rectangle class instead, and we've made a rectangle of dimensions 5 by 3. So although the declared types for both GeoObject1 and GeoObject2 are geometric object, the actual type for object 1 is a circle, while for object 2 it's rectangle. Now immediately in the next line you may begin to understand why what we did in terms of abstract functions is significant here. Notice that we're doing a system out print line with a little message that says the two objects have the same area question mark, and then we're going to print a Boolean result equal area with two objects as arguments, GeoObject1 and GeoObject2, the two objects that we made up above. If you go down and find the definition of equal area of that method round about the middle of the slide there, you'll notice that it accepts geometric objects as arguments. Now before, our geometric object class did not have a getArea method. In a sense it still doesn't because it's only an abstract function, but because it is there, abstract though be it, we can now use it. We can now actually say object1.getArea. The trick now is that it's not defined directly inside of geometric object because it's only abstract there, which means we will have to go to the actual type of object 1 to find the implementation of the getArea function. So if you look carefully at this line where we're returning the Boolean result for equal area, the line says return object1.getArea equals object2.getArea. In both cases, these are geometric objects, at least that's how they've been declared, and we're using the getArea method with each of them because it does have a geometric, or the geometric object does have a getArea method. But because it's abstract, we can't actually execute code from there. We have to go to the actual type in each case, and we're going to execute different getArea methods for each of these objects. Because object 1's actual type is a circle, we are going to execute the getArea method for the circle in the case of the operand on the left hand side of the equals equals, whereas object 2 is a rectangle, so on the right hand side of the equals equals operator, we're instead going to be executing the getArea method of the rectangle. In other words, we're going to execute the appropriate getArea methods for the actual types of objects that we have been passed to use. In the bottom of the slide, the same principle applies. We've defined a display geometric object method that takes a geometric object as an object and yet it executes the appropriate method for get area and get perimeter. First of all, we're allowed to say object get area and object get perimeter because those methods are in fact shown and exist inside of our geometric class. There's no implementation, but we do have these placeholders which allows us to do this now. However, because the implementation is not there, we're still going to depend on knowing what the actual type of the object is and executing the get area and get perimeter methods that are associated with the actual type instead of the geometric object. So when we call display geometric object with an object that's got an actual type of circle, then we're going to execute the get area that goes with circle and get perimeter that goes with circle. On the other hand, if we pass it an object whose actual type is a rectangle, then when we execute get area and get perimeter, we're going to execute the appropriate methods that are defined in rectangle instead. A concrete class is not